Okay, so we've got question 18 here, and it says work out the length of BC. So we've got to work out this distance here. So it's not a right angle triangle, so we can't use traditional the Sokotoa method, and we don't have matched pairs. So for example, this side here hasn't got an angle here, this side here hasn't got an angle here, so we don't have matched pairs. So we're going to have to use something called the cosine rule, and the cosine rule is at the beginning of the exam paper. Okay, and the cosine rule says that a squared equals b squared plus c squared minus 2bc cos a. Okay, so you don't have to remember this, only sad people like me need to remember it. So this is big A, so this side is going to be little a, and it doesn't matter which you label these, A or B or C, so we just label this B and we'll label this C. Okay, so little a is always directly opposite big A. Okay, and if you want big B, we have little b, and then big C, we have little c. Okay, so now it's just a question of transposing all of those numbers into this. So a squared equals, now b squared, now b is 45, so that's going to be 45 squared plus c squared, so that's 60 squared minus, and this is going to be 2 multiplied by b, which is 45, multiplied by c, which is 60, multiplied by the cosine of the angle A, which is 110 degrees. So a squared equals, so now we go to the calculator, 45 squared is 2025, so we've got 2025 plus, clear that, we have 60 squared is 3600, so we have 3600 minus, now I just do this all in one fell swoop on the calculator, so I just go 2 times 45 times 60 times cos 110, and that will give me minus 1846, so that's minus 1846.908. Okay, so it says take away whatever the result of that is. Now the result of that is minus that, so we've got to take that away. So two minuses make a plus. Okay, so we have a squared equals, so now we're going to have 2025 plus 3600 plus 1846.908 equals, so I get 7,471.908. Okay, now I know that looks a massive number here, 7,000, and this is 45 and this is 60. But don't forget that's a squared. So a is going to be the square root of that. Sorry about the wonky line. 7,471.908. Okay, so I need to find the root of that number. So the root 7,471.908 equals 86. So we get A equals, well, I get 86.44. Okay, so I would get 86.44 kilometers. So I understand this looks horrible. I understand that. Most people will avoid the cosine rule like the plague. But the calculator really does it all for you. The only thing you've got to be careful of is remember that this says take away whatever the result is of this. Now because the result is minus, it means take away minus that. Because the two signs can touch, this means that we must add. Okay? Then it's fairly simple after that. And 86, well, that seems to fit fairly okay. If this is 45 and this is 60, this looks the longest side. I know it's not drawn accurately, but this will be the longest side. So something around about 80 would be reasonable. Okay, so that's question, sorry, jerking the page up and down, that's question 18, so I'll go on to question 19. Okay, question 19. Luke has a rectangular garden. The length is 40 metres, the width is 25 metres. Both measurements are given to the nearest metre, so this is important, the nearest metre. Okay, so we're dealing with upper and lower bounds. Myra also has a garden. The area is 970 metres squared to the nearest 10 metres squared. She thinks her garden has a bigger area. Is she correct? Okay, and we have to show our workings. Okay, now the area of her garden is 970 metres squared to the nearest 10 metres. Okay, so that will be plus or minus 5 metres. Okay, it could be 5 metres squared either way. We just take this and halve it. So the smallest their garden could be would be 965 metres squared. The largest their garden could be would be 975 metres squared. Okay. Now it says here that these measurements are to the nearest metre, so again it's plus or minus half a metre. So this, the smallest it can be would be 39.5 metres. The largest it can be is 40.5 metres. Again here the smallest this could be is 24.5 metres and the largest it can be is 25.5 metres. So she thinks that her garden has a bigger area, so really what we need to do is find out what's the smallest area this garden could be, what's the largest this area garden could be, and then compare it. Okay, it really is that simple. So Let's work the smallest, so that's 39.5, so the smallest area, okay, will be 39.5 multiplied by 40.5, 39.5 by 24.5, by 24.5. I'll just check. Sorry about moving the page up and down so much. Okay, so that would be the smallest area of garden that Luke could have. So that would be 39.5 multiplied by 24.5. That gives us an area of 967.75, and that will be meters squared. Okay, and I better write here Luke. And then the largest area that Luke could have, now this would be 40.5 multiplied by 25.5. Okay, that's taking it to its largest measurement. So we have 40.5 multiplied by 25.5 equals, now that's 1032.75, and that's meters squared. Okay, so we've shown our working, we've shown why it is what it is. Now Myra's garden is 965 or 975, so this is Myra equals 965 meters squared or 975 meters squared. Okay, well, if we work to the smallest area, in theory she's right, because it would be less than her largest area. But if we take Luke's largest area, then she's wrong. So I would say that you can't tell, because using one set of measurements, 965, and 975, using her largest measurement of 975, that is bigger than Luke's smallest measurement. But 965 and 975 are smaller than Luke's largest area, so we can't really tell. She's not correct, but she's not incorrect, so we can't tell. Okay, sorry, it's not really a cut and dried question. It's not really the greatest question in the world, but I hope you understand that you need to work to, whenever you see the nearest, then you just go half of whatever the nearest is up and down. So a metre, so half a metre up, half a metre down. The nearest 10 metres, then 5 metres up, 5 metres down, or metres squared. Okay, so I'll move on to the next question. Okay, so question 20. Y is directly proportional to r squared. So I can write this down already. Y is directly proportional to r squared when r equals 4 and y equals 24. So then they say work out the value of r when y equals 1350. Okay, so y is proportional to r squared. Okay, so therefore y equals k r squared. Okay, remember k is the constant of proportionality. Okay, so this is true when r is 4 and y is 24. So y now becomes 24, and that equals k multiplied by r squared. Now r is 4, so this is 4 squared. Okay, so I can say therefore 24 equals, now 4 squared is 16, 4 fours are 16, and 16 times k is 16k. So I can say that 16 goes into 24 1.5 times, so 1.5 equals k. You'll notice I haven't suddenly flipped everything around. Okay, k has stayed on the right hand side. So my constant of proportionality k is 1.5. So then they say work out the value of r when y equals 1350. So we can say again y equals k r squared. So I can say now if y is 1350, then that equals 1.5 multiplied by r squared. So this is 1.5 r squared. Okay, this is 1.5 lots of r squared. Okay, so I want to know what r is, so I want r squared on its own. So I'm going to move this 1.5 over. It's multiplying, so it's going to divide. And this will make most mathematicians cringe, but go with me on this. We have 1350 divided by 1.5, and that will equal r squared. Okay, the reason why I say that mathematicians will cringe is because you shouldn't have a fraction within a fraction. Okay, what I could have done is multiply both sides by 2 so that I get 2700 equals 3r squared. But I'm just keeping this simple so you can see, and it's a calculator paper anyway. So now what I need to do is find out what 1350 is divided by 1.5. So 1350 divided by 1.5 equals 900. So I can say 900 equals r squared. Okay. Therefore, now if r squared equals 900, then the root 900 must equal r. Okay. Now if you put this in your calculator, you'll see that it comes up square root of 900 is 30. Okay, so we can say that r equals 30. But what you've got to remember is that the root of any number is plus or minus. Okay, so I would say plus or minus 30 equals R. Okay? Sometimes you're not going to use the negative. For example, supposing we were working out, this was a cube, say, and we know that the two sides multiply together. So let's say the sides were marked R and R, then R squared will be the area. So we want to find what one side is. We find the root, so we know it's 30. We don't usually get a negative 30 centimetres or a negative 30 kilometres, so we always go with the positive. But here they've just said work out the value of R. So there are two possible answers. If you just put plus 30, maybe you might drop a point, half a point, but it's always worth remembering. Okay, so for 5 marks, I think that's quite a nice simple question. Okay, so these are worth practicing. Okay, so I'll go on to the next question. Okay, so question 21. Solve the simultaneous equations y equals x equals 2 and y equals 2x squared plus 5x plus 1 with your answer to correct to 1 decimal place. Okay, so here we have a linear equation. Okay, this is a linear equation, usually comes in the form of y equals mx plus c. That's a linear equation. This is a quadratic equation because we have x squared. Now, what I'd like to do is not do the question, but given that I've got to do the question, I need to put this equation into this form, and I'll explain why when I've done it. So I want the y on its own, so this minus x is going to come over and the sign will change, so then I get y equals x plus 2. Okay, so this equation is this equation, it's the same thing. Now if y equals this and y also equals this, then this must equal this. Okay, so if y equals this and y equals this, then that must be the same as that. So instead of, and this is a quadratic equation by elimination, we're eliminating the y's altogether, okay, or by substitution, sorry. So I can say 2x squared plus 5x plus 1 equals x plus 2, because this equals this. So therefore, now this is a quadratic and all quadratics equals 0, so this x plus 2 is going to have to come over the other side, so we get 2x squared plus 5x plus 1 minus x minus 2 equals 0. Okay, so now I just tidy this up, so I have 2x squared, now 5x minus x is plus 4x, and plus 1 minus 2 is minus 1, and that will equal 0. So it says give your answers correct to 1 decimal place. Now if it's to 1 decimal place, I know this isn't going to factorise. So the only way to solve this, well, there's 2 ways. I could complete the square, which I don't really want to do because I would get into fractions, is to use the quadratic formula. Okay, so the quadratic formula again is given at the beginning of the page, first page of the exam paper. So x equals minus b plus or minus the root of b squared minus 4ac, and this is all over 2a. Okay, and people are afraid of this, but there's no need to be. Now this is just, apart from the 2 and the 4, this is just a's, b's and c's. Now a is the number of x squareds, b is the number of x's, and c is your number at the end. So now I can substitute these values in to here. This is why it's worth 6 marks. So x equals, now it says minus b. Now if b is 4, then that's minus 4 plus or minus the root of b squared. Now b is 4, so it's going to be 4 squared minus, now I always put a bracket in here, 4 multiplied by a, which is 2, multiplied by c, which is minus 1. And we can close the bracket. And this is all over 2a. Now a is 2, so 2a would be 4. So now we can sort of dilute this. All that's going to happen is this root now is going to shrink. So we get minus 4 plus or minus the root of, now 4 squared is 16, and it says to take away whatever the result of this is. Now 4 times 2 is 8, 8 times minus 1 is minus 8. So we get minus 8. Okay, so I hope you can see that. 4 2s are 8, 8 times minus 1 is minus 8, and it said to take away whatever that is, so we take away minus 8. And this is all over 4. Now, a minus and a minus will give us a plus. So therefore, x equals minus 4 plus or minus the root, now 16 plus 8 is 24, and this is all over 4. Okay, so I'm hoping you're still with me and that you're not crying too much. So now I can say x equals minus 4 plus or minus, so I need to now know what the root of 24 is, so I go root 24 equals, now that gives me 4.8989, so I get 4.8989. Now you'll notice I've gone to 4 decimal places there. That's because I want to make it as accurate as possible, because I've got to give my answer to 1 decimal place. Now because I've got a plus and a minus here, this is going to give me 2 values for x. So let's say I go with the plus. So I can have x equals minus 4 plus 4.8989 all divided by 4. Okay, again obviously it's a calculator paper, so I put into my calculator minus 4 plus 4.8989, and I've got to divide that by 4, which gives me 0.22. Okay, so I get 0.22. So x will equal 0.22. Now I also have minus 4.8989. So this will be minus 4 minus 4.8989, all divided by 4, which equals, so that's going to be minus 8.8989 divided by 4 equals 2.22. So I get minus 2.22. And I clear that. Okay. So I now have my two x values, but I've also got to find out what my y values are. So I'm going to take this equation here. I could put it in both of these equations, but this is a nice simple equation because I've got to find y. So y equals x plus 2. So if y equals x plus 2, then y would equal, now if this is 0.22, this would be 0.22 plus 2. So I can say that y equals 2.22. Now I also have y equals x, which is minus 2.22, again plus 2. So therefore y would equal minus 0.22. Now it does say give your answers correct to 1 decimal place. So I can say that x equals now 0.22 to 1 decimal place would be 0.2, and that y would equal, now it wouldn't be 2.22, it would be 2.2 because it's to 1 decimal place, or x equals minus 2.2, and that y would equal minus 0.2. Okay, so you can see there why it's worth 6 marks. Okay, so it's just a question of being careful and working your way through it, and obviously it's question number 21, so it's right at the back end of the paper, and historically the last few questions are always like this. Okay, I hope that's helped. I've tried to explain it as best I can. Even if you can get part of the way there, then at least you're picking up some points. Okay, so I'll move on to the next question. Okay, 22. We're getting there slowly. Simplify. So obviously this fraction is going to cancel. Now this is what I call a gift from God, x squared minus 16, because it's the difference of 2 squares. So x squared minus 16 can be factorised as x plus 4, because the square root of 16 is 4, and x minus 4. Okay, so that's nice and easy. Now, the 2x squared minus 5x minus 12. Now, this will factorise again. This will go into 2 brackets. Okay. one of these brackets has to cancel with one of these brackets. So one of these brackets is going to have x and a 4 in it. Whether it's plus or minus I don't know yet, but I know it's going to have x and 4 in it for it to cancel. Now the only way I can get 2x squared is to have 2x multiplied by x. So this bracket is going to have 2x in it. So now it's just a question of what times 4 will give me 12. Now I know that 3 times 4 will give me 12. All I've now got to decide is that for 3 times 4 to give me 12 is for me to get minus 12, one of these is going to have to be a plus and one is going to have to be a minus. Okay? So, I can just play with this. Okay? I can just play with this. So let's say that I say this is plus 3 and this is minus 4. Now I know that 2x times x gives me 2x squared. I know that plus 3 times minus 4 gives me minus 12. What's important is, can I get the minus 5x? Now 3 times x gives me 3x. Now 2x multiplied by minus 4 gives me minus 8x. Now 3x minus 8x does give me minus 5x. So I know that my signs are in the right place. If I'd have put the minus here and the plus here, multiplied it out, I would have found out that it wouldn't have worked, so then I could just switch the signs. Okay? So you'll know this just by doing this over and over and over again. It becomes instinct. So now I can see that the x minus 4 and the x minus 4 can cancel. Now x plus 4 and 2x plus 3, they can't cancel. There is nothing in common with those two. So I have x plus 4 on the top, and I have 2x, and I think was it plus 3? Yeah, plus 3. So that's it, I've simplified it. Okay, the key is this. Okay, this will help you solve this. So it's just a question of logic. Okay, I hope that's helped, but this, the difference of two squares, I call a gift from God, is very, very useful because it helps me factorize this equation very quickly. Okay, so I'll move on to the next question. Okay, a bag contains 9 counters, 4 of the counters are blue, 2 counters are taken out of the bag at random. Calculate the probability that at least one of the counters is blue. At least one. Okay, so they leave us a gap here before the lines. So they're showing us that they want a tree diagram. Okay, so first off we have our first choice. Behave. Okay, so we have our first choice. So we have blue, and they don't tell us what the other counters are. So we have blue and not blue. So we have blue and not blue. So 4 of the counters are blue. So the probability of pulling a blue is 4 of the 9. So the probability of not blue is 5 of the 9. Okay, Then a second choice is made. Okay, a second choice is made. So again we have blue, not blue, blue, not blue. Now if we'd have chosen a blue on the first go, then there's one less blue, but there's also one less counter. So there's 3 of the 8 counters. So the remaining counters must be not blue. So there must still be the original 5 of the 8 counters. Okay, remember all probabilities add up to 1 anyway. So if I'd have chosen a blue on the first go, there'd be one less blue, but also one less counter. So this would be 3 over 8, so the remainder must be 5 over 8. Now if I'd have chosen a not blue on the first go, there'd be one less counter that's not blue and one less counter in the bag. So that will be 4 over 8. So all probabilities add up to 1, so this must be 4 over 8. So now I have my tree diagram. Now it says calculate the probability that at least one of the 2 counters is blue. Now that could be a blue and a blue, a blue and a not blue, a not blue and a blue. Now that's 3 calculations. I really can't be bothered with working out 3 calculations. What I can be bothered with is knowing that the only way I can't get a blue would be not blue and not blue. I hope that makes sense. This is the only way I can't get a blue. Okay, is not blue and not blue. There is method in my madness. So not blue is 5 over 9. The and or rule says and says multiply, and not blue on my second choice would be 4 over 8. Okay, so if I multiply this across, 5 4s are 20 and 9 8s are 72. Now that's the probability of not blue and not blue. Now all other probabilities mean that I'll get a blue. So if I take 20 over 72 away from 1, that will give me all the other probabilities. So 20 from 72 is 52 over 72. So that would be my answer, 52 over 72. Okay? There's no need to cancel down. You can if you want to, but you don't have to cancel down. Okay? So whenever it says in a question, at least something, I always work out, well, what's the only way that that can't happen? And then I take it away from 1, and that will always give me the answer that I want. Okay? The tree diagram is very, very important. Okay, we'll move on to the next question. Okay, so the final question. So we have to prove that this minus this will give us this. Okay, these 3 lines means is exactly the same as or is congruent to. So this fraction, take away this fraction, should yield this. Now, like any other fractions, if we're going to add or subtract, we need a common denominator. So I'm going to multiply these 2 together. Now rather than multiply out, I'm just going to go 3n multiplied by n minus 1. And you can see there that we've already ticked that box. Okay? Because that times that will give us our common denominator. So now what we need to do is this. 3n will go into this n minus 1 times. So I've got to multiply 3n plus 5 by n minus 1. Okay? And I've got to subtract. Now n minus 1 will go into this 3n times. So 3n multiplied by n. Okay, I hope you understand that. So 3n will go into this many times, so then we multiply the top by this, and then n minus 1 will go into this 3n times, so then 3n has to multiply the top. So now we just tidy this up. So 3n multiplied by n is 3n squared. 3n multiplied by minus 1 is minus 3n. 5 multiplied by n is plus 5n. And plus 5 multiplied by minus 1 is minus 5. And then minus 3n multiplied by n is minus 3n squared. Okay, and all of this is over 3n multiplied by n minus 1. We don't need to touch that because it's already there. So now all we need to do is tidy this up. Now n squareds, I've got plus 3n squared and minus 3n squared, so they cancel one another out. Now minus 3n plus 5n leaves me 2n, and I'm left with the minus 5, which is what we want. So 2n minus 5 all over 3n n minus 1. And we've proven that it does indeed make that. Okay? This is fractional algebra and it can get a bit fiddly, but if you understand that this goes into this many times and then you're going to have to multiply the top by that, then you're off and running. This just takes practice. Okay, hope that's helped, and just keep practicing and good luck.